So we're going to look at another example involving directional derivatives, but I do want to make one note before we do this. Remember that the vector u must be a unit vector. If it is not, you're going to have to turn it into a unit vector. We're going to have to divide by the magnitude. So let's look at an example. Find the directional derivative of the function. It'll be x squared sine 2y at the point 1 pi over 2, and the direction of the vector v, which will be 3i minus 4j. So I'm going to start by finding my partial derivatives. Fx will be 2x sine 2y, and then Fy will be 2x squared cosine of 2y. Now if I look at my vector v here, my direction, this vector is not a unit vector. So we're going to have to turn it into a unit vector. So the first thing I'm going to do is find the magnitude of v. That's the square root 9 plus 16, 25, which is 5. So then my vector u will be given by v divided by the magnitude of v. So u will be 3/5 I minus 4/5 j. And this unit vector, remember, it's given by cosine theta I plus sine theta j. So in particular, I know that cosine of theta is 3/5, and I know that sine theta is negative 4/5. So now I'm ready to find my directional derivative. du, it's my partial derivative with respect to x, so it's 2x sine 2y times cosine theta, which was 3/5, plus my partial derivative with respect to y, which was 2x squared cosine 2y, times sine of theta, which was negative 4/5. So now all I've got to do is plug in my point, and in my point I was told x equals 1, y equals pi over 2. So plug that in to get my directional derivative. So I'll get 2 sine of pi times 3/5 plus 2 cosine of pi times negative 4/5. Well, sine of pi is 0. Cosine of pi is negative 1. So you'll get positive 8/5 for the directional derivative. And again, this is a scalar, it's a number.